Hello and welcome. In this video we're going to talk about using z-values to determine percentages. Now, like any math problem, word problems are what students struggle with the most. And when it comes to word problems with normal distributions, that's, again, just like any other problem. It can be very tough to start. Now, what I want to focus on is not the actual word problem part. We will do some word problems. But once you get the word problem and you figure out your z-value, I want to go over what to do with those z-values to find the percentages. Now, for the moment, I'm not going to worry about what mu is, like what the number is, and I'm not going to worry about the standard deviation, because the only way we use those is to determine the z-value. What we're going to do is we're going to start with knowing it. All right. So, for example, let's say this is how we would represent, say, 1.5 standard deviations away. So just so you understand what this notation means, say, for example, you had a test score of 70. And so we had a mean of 70 and a standard deviation of 10. So what would this number represent? Well, it would represent 70 plus 1.5 times 10, which is 85. So what this score 85 is represented by this expression, but the only thing I need to know in this entire thing is the 1.5. So let me write this expression up here. It's mu plus z times sigma. Okay, because the number in front of sigma is going to tell you how many standard deviations you're going away. Okay, so here's our example. So I want to know what percentage is between 70 and 1.5 standard deviations away. Remember, we have a normal table that will do that. Now, in the normal table, if you look at 1.5, which is right here, that's 43.3%. So in this example, the percentage of people who score between a 70 and an 85, or more generally between the mean and 1.5 standard deviations, is going to be 43.3%. Now, the thing that I want to get across is it really doesn't matter what these numbers are. Okay, all that matters when we're dealing with normal curves and the percentages is just the z-value. That's all I need. Okay, so here's one example. Let's move on to another one. Now, in this example, I want to find the percentage between this number here and that number. Again, if we let mu equal 70 and our standard deviation to be 10, then if you do the math, and I'll let you do that, this would be 55, and then this would be 78. So with this example, I want to know the percentage of people who scored between 55 and 78. But again, all I'm going to use, or all I need, are the standard deviations. Okay. Now, this table that I have over here, look at this picture. This picture is only associating z-values with percentages, but the percentages have to be between the mean and your particular value. So notice that in our example, we have two particular values. So even though that I want to find the percentage in this entire region here, okay, we do have to do these separately. So we're going to have to do the percentage in here first, okay, using the z-table. So let's go back and do that. So again, I don't really worry about the negative. It just means that we're on the left-hand side of the mean. But I am exactly 1.5 standard deviations away. Now, 1.5 standard deviations is 43.3%. This is right there. So that means the percentage in here is 43.3%. And then we move on to the next part, between the mean and 0.8 standard deviations. So if we take a look at our normal table, 0.8 is 28.8%. So that means between the percentage between the mean, that table only tells you the percentage between the mean and your particular value. So in our case, it was 28.8%. So if I want to know the percentage between these two numbers, whatever, if in our example it's a 55 and a 78 test scores, we would just add these two percentages together. So 43.3 plus 28.8 equals 72.1%. Our next example, let's say again you had a word problem and you needed to know what percentage was actually below a certain number. Okay, so again with our example of 70, I'll let you plug in all the information. In this case, it's going to give us a score of 49. All right, so what percentage of people scored below a 49? So even though that this number here, 49, is exactly 2.1 standard deviations away, you have to remember that when you look at our table, which I'll bring up right now, 2.1 is right here, so that's 48.2%. Okay, but where does that 48.2% go? And it doesn't go here, okay? It doesn't go there. It goes here, 48.2%. So you might be thinking, okay, well then how do we find this region? Well, it's really not that hard. Okay, remember that the characteristics of a normal curve, or one of them is that the mean, median, and mode are all the same, and that the second characteristic is that it splits the normal curve in half, which means this entire side here is 50%. And then this other side over here is 50%. So if this entire side is 50% and this is 48.2%, then how do we find this region right here? Well, you would just take 50 minus 48.2. And that equals 1.8%. Okay. Now what if you had a follow-up question or a completely different question, but it said, what percentage is above 49? Okay, so then I would be looking for all of this. Well, you found that this is 48.2%, but then what's all this? Well, it's all 50%. So from here and greater than, you would add 48.2 and then 50% to get 98.2%. In our final example, I want to find the percentage between mu plus 0.3, so go up 0.3 standard deviations, between that one and then between 2.5 standard deviations. So if you plug in all our information we have right here, then this would be 73, and then this would be a 95. So in this case, I'm asking what percentage of people score between a 73 and a 95. All right, well, if this was a word problem, you'd have to find the z-values, but we already know the z-values. We have 2.5 here. Now what happens when we go and look up 2.5 in the normal curve, or normal table? It's 49.4%. But remember, down here, that 49.4% represents the percentage between the mean and your particular value. So if you bring your 49.4%, that percentage is this entire region. Okay. Now what region is it including? It's also including this region here, because it's, again, between the mean and your particular value. I don't want this region. So my answer is not 49.4%. I need to figure out what this percentage is and then subtract it off. Okay, so I need to find the z-value. Well, I already know it. It's 0.3. So let's go ahead and take a look at what 0.3 is. 0.3 is 11.8% right there. So then I know that this region right here is 11.8%. So if this entire thing is 49.4, and I don't want this 11.8, then all I'm going to do is subtract it off. And that's going to equal 37.6%. So this region in here, okay, the people who scored between a 73 and a 95, that's 37.6%. So hopefully giving you a variety of scenarios will help you, because once you have a word problem, all you have to do is figure out what the z-values are and also figure out what regions you're trying to find. That's why I'm shading these. It helps me remember what region I'm trying to, or what percentage in what region I'm trying to find.